In this video, we want to look at geometric distributions rather than binomial distributions. So if you remember when we studied binomials, we used BINS, B-I-N-S. We had to have a binary outcome, either it was a success or a failure. The trials had to be independent or close enough to independent if our sample size was less than 10% of the population. And then there was this fixed number of trials. That was your bin, or your I in BINS. And then the S was that the chance of success stayed the same for each trial. So this would be something like, maybe I'm going to flip a coin 10 times, and I want to know what are the chances of getting a heads 6 of those 10 times. That would be binomial or BINS. Now what I'm changing it to is, rather than having a set number of times that I'm flipping the coin, I'm going to flip the coin until I get a success, until the first time that I get a heads. So it's no longer a fixed setting, and there's no longer an N for BINS. Now we're going to change it to a T for bits. And this T is just the time until you get your first success. So maybe I'll say, now I'm going to flip the coin until I get a heads. What are the chances that the first time I get a heads is on the 6th flip? So let's look at how this might look. Let's say I was thinking of a day of the week, so either Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. And I asked all of your classmates and you to guess what day I was thinking of. You wrote it on a piece of paper and turned it in. And then I was going to pull out one of those pieces of paper and see if it was the first student that correctly guessed the right day of the week. Or maybe it's the second, or the third, or the kth student that was the first one that guessed the correct day. So the chance that it would be the first student is 1 out of 7, because you have a 1 out of 7 chance of guessing the day correctly. Now, if I want to find the chance that it's the second student, that means that the first student guessed wrong, and there are 6 days of the week that are wrong, so there's a 6 out of 7 chance that they guessed wrong. And then there's a 1 out of 7 chance that that second student got correct. So and means multiply. Here's our chance that the second student got it correct. If it's the third student guessing the day correct, that means that the first 2 got it wrong and the third one got it right. And you can start to see a pattern here where one person is going to get it right. That's your last person, so that's your P, the probability that that last person got it correct. And then all of the people prior to them got it incorrect. That's your 1 minus P. That's your probability of failure. And if there's K people, it's that kth person that got it right. That means everyone before them, so 1 less than K, that got it wrong. So that's where this formula is coming from. Here is the distribution for this problem. So we've got our table, and notice how there's a little dot, dot, dot here to show that it goes on forever. Because technically, although the chances get lower and lower, eventually, it's possible that I could go very many people without getting the correct answer. And that also shows out over here, how this tail kind of drags out for a very long time. So it turns out that every geometric distribution, not just this one, but they will always be very heavily skewed to the right. Now, in terms of the center, if I want to find the mean will be found through the formula 1 over P, where P is the chance of success. So for this problem, that would be 1 over 1/7. And of course, remember that dividing by a fraction is the same as multiplying by the reciprocal. And that's where we end up with this mean of 7. To find the standard deviation, we're going to use the formula where we take the square root of the chance of failure and divide that by the chance of success. So again, our P, our chance of success here, is the 1/7. And if we were to do this calculation, that's where we're getting the 6.48, or the standard deviation. Now, just like you could use your calculator to calculate binomial probabilities, you can do the same thing for geometric. So you're going to go into that distribution menu, and you're going to look for the last 2 items on the list. They're near the bottom for geometric. And here is kind of the setup that you'll use. Just like you had a PDF and a CDF option for binomial, you have the same thing for geometric. So if I wanted to find the probability that the first student that guesses it correct was the 8th student, I would put in an 8 for the n here, the number of students until the first one got it correct, and then the p, that's my 1/7, my chance of getting it correct. That would give me the chance that it was exactly the 8th student that got the question correct. If we put that in our calculator, we're going to get that it's about a 5-ish% chance that it's the 8th person, that's the first person that guesses the day of the week correctly. For CDF, remember, it means that person or before. So if I put in the same thing with a CDF, that would mean what are the chances that the 8th person or the 7th or the 6th or the 5th, all the way down to the first person, what are the chances that the 8th person or before guesses the correct answer? You can put that in your calculator, give it a try, and that works out to about 71-ish%.